Let's go over the answers to the combination decomposition reactions. So first one we've got is you have HF. And you got this Roman numeral 4 in parentheses. What does that mean? What that means is when it actually comes over the other side, that's going to be its charge. Right now, we just have one HF or hafnium. Now, it doesn't mean that I have 4 of them. I only have one, but it's going to have a +4 charge when it comes to the other side. Then we're going to plus diatomic nitrogen. This is combination, so we're just going to combine these two. But remember, you don't bring any of the numbers down below over. So we're going to take HF, and we're going to take N, put them together. Then it said HF has a +4, N from the periodic table has a -3. Do those charges cancel each other? Nope. So we got to crisscross them. So I'm going to make this 4, and this one 3. So that's my formula. Now what I got to do is now I got to balance them. So I have an HF here, plus I got 2 N's, and that's equal to, I'm going to sneeze, 3 HFs and 4 N's. Excuse me. Excuse me, goodness. All right, so I got 1 HF, I got 3 HFs. So I need another HF. So there's my 3 HFs. Then I got 2 N's, 4 N's, so I need some more N's. And there's my final answer. So I have... excuse me, goodness. Must be allergic to somebody. I got 3 of that, 2 of that, and 1 of that, so I leave it blank. And there's my answer for that one. Now, don't forget, these Roman numerals, those only mean charges. They don't mean how many there are. Okay, so again, there was only 1 HF there, not 4. All right, let's go over the next one. Next one says Cu, and again, we got the Roman numeral 3 in parentheses, plus Cl2. So again, in Roman numeral 3, that just means that it's going to have a +3 when it joins up with somebody. So we're going to have Cu and Cl. Don't bring the 2 across. The 2 is there because he's diatomic. We get to the other side. This guy's +3. This guy's -1 from the periodic table. Those don't cancel each other, so we got to crisscross it. So we're going to bring the 3 over and make that CuCl3. Now I have to balance this. So in here, I've got 1 Cu plus I've got 2 Cls. And that's equal to a Cu and 3 Cls. So I got 1 Cu, 1 Cu, I got 2 Cls, 3 Cls. Oh, that's an even and an odd. So that means I go back to the first one, double it. Oops, let's make that look like a Cu, that'd be better. Cu, and start all over. So 2 Cus, now I need another Cu. Okay, now my Cls, I got 2 and I got 6. So I need some more here. There's 4. There's 6. So there's my final answer. So 1, 2, put a 2. 1, 2, 3, put a 3. 1, 2, put a 2. And that's the final answer for that one. All right, on to the next one. All right, next one, we got Na plus P. So sodium plus phosphorus. All right, so we bring over the elements, we bring our Na and P and put them together. Then I do charges, periodic table, Na is +1, P is -3. You got both of those from the periodic table because they're just elements. Crisscross those, so I'm going to end up with 3 here and nothing next to the P because it's just a 1. Now I'll do my circles. I've got an Na plus I got a P. That's going to be equal to 3 Nas and 1 P. All right, so I got 1 Na, 3 Nas. So I need some more Nas. There's my 3 Nas. And I got 1 P and 1 P, so that's it. So that means I got 3 of this guy, 1, 1, so I leave those blank. And there's my answer for that one. All right, next one for combination. All right, we got Ca plus Bi. All right, bring them both across, Ca and Bi, put them together. Calcium, he's a +2. Bismuth, I gotta look him up, I'm not familiar with him off the top of my head. There he is. He's a -3. So Steve and I have to look him up once in a while on the periodic table. I don't know them all. All right, crisscross it. 2 goes there, 3 goes there. My periodic table is up above. That's why I was looking up. All right, now we got to balance this thing. So I've got 1 Ca, got 1 Bi, that's equal to, I got 3 Cas and 2 bismols. So I need some more Cas. There's my 3 and 3, and I need another bismols. 1, 2, 1, 2. There's my final answer. So I have 1, 2, 3, put a 3. 1, 2, put a 2. 1, leave it blank. And there's my final answer, saying that 3 calciums plus 2 bismuls will make Ca3Bi2. All right, next one. All right, PdV, palladium, and then we got Roman numeral 5 in parentheses. Again, that means it's charged. This is a special one that he's got a Roman numeral 5, so he's a plus 5. Plus S. So when I come across, we got PD, he's got a plus 5 because of that Roman numeral 5. And then we got with S, he's a negative 2 from the periodic table. So crisscross those, we're going to go 5 and 2. Then we got to do our circles. So we have a PD. There's only one of them, not 5, that's just charge. Plus, we have an S, and that's equal to, we got PD, PD, and then I got 5 S's. So I'll do my balance them out. I need another PD over here. That gives me 2 and 2. And I need 5 S's, so I need 5 of these guys. And that makes me even now. So I got 2 of this guy, 5 of that, and 1 of him, so leave it blank. And that's the end. All right, now we go on to decomposition, which, remember, decomposition is kind of the reverse of these because we've been putting these together because it's combination. Now we're going to decompose them, we're going to tear them apart. So my first one is AgO. So I'm going to tear them apart. I take the 2 elements, I get Ag plus O. That plus means that they're separate now, they're not put together anymore. All right, now you look at them and say, are they diatomic? Is Ag a diatomic dude? Nope, he's not one of the 7. Is O a diatomic dude? Yes, he is. So I got to put a 2 by him. All right, now that I've done that, now it's time to balance it. So I go, I got 1 Ag and I got 1 O. That's got to be equal to 1 Ag plus 2 O's. Ag is 1, 1. O is 1, 2. That's an odd and even, so come over here and redo this one. Which that actually makes my O's even. So I got 1, 2, 1, 2. Now I got 2 AGs and I need another AG. So balance these guys out. I got 2 and 2. And leave this guy blank because there's only 1. All right, next one. All right, next one, Al2Se3. All right, so we're going to tear these apart because this is decomposition. So we're going to get Al, don't bring any numbers across, it's just the symbols. Al plus Se, that's all. Now is Al, is he diatomic? Nope, he's not one of the 7. Is Se diatomic? Nope, he's not one of the 7. So they just stay as singles. Now I got to balance it. So I've got 2 ALs and I got 3 SEs. That's going to be equal to an AL plus an SE. So I got 1, 2 ALs. I need another AL. There's my 2 ALs. I got 3 SEs, so I need some more of these guys. And that makes it balanced. So I got 1, leave it blank. 1, 2, put a 2. 1, 2, 3, put a 3. All right, next one. Next one, AuBr2. Decompose it, tear it apart. So I got Au plus Br. Don't bring any numbers across in this one. Remember, the only numbers you ever bring across are the ones that come from the polyatomic ion page, right? Which we'll get to later. So I'm doing that when they come across, but that's the only time you're going to bring numbers across, ultimately. All right, is this guy diatomic? Nope, he's not, so he just stays as 1. Br diatomic? Yes, he is. So we put a 2 there. Now note that, yep, he has a 2 there, but it's not because he had a 2 over here, right? He's a 2 over here because he was diatomic. Now to balance it, turns out it's balanced the way it is. I'll do the bubbles anyways. Well, we got an AU, BR, and a BR. That's going to be equal to an AU plus a BR, BR. Is everything even? Yep. So this is a 1 to 1 to 1 to 1. All right, got two more. All right, InH3, indium hydride. All right, tear these two guys apart. We got indium, In, plus hydrogen. Remember, don't bring any numbers over. Indium, In, is he a diatomic? Now you might look at it and go, well, it's iodine. Nope, it's not iodine. This is In. This is a different element. So nope, he's not diatomic. Is H diatomic? Yes, he is. He is one of the diatomic dudes. All right, let's do our circles. We got an In, and I got 3 H's. That's equal to 1 indium plus 2 H's. I got 1 indium, that's even. H's, I got 3, got 2. Oh, that's an odd and even. So we'll go over back, do it again. Start all over. Now I got 2 INs. So I need 2 INs. I got 6 H's. I need some more H's. There we go. Now he's all done. I got 1, 2, do a 2. 1, 2, put a 2. 1, 2, 3, put a 3. There's my final answer on that one. Got one more. Last one, CS4C. So bring over CS plus C. Don't bring any numbers over. Right? Is this guy diatomic? Nope, he's not diatomic. Is carbon diatomic? Nope, he's not either. So now I just do my circles. I got 4 CS's and 1 C. That's going to be equal to a CS plus a C. I got 4 CS's. I need some more CS's, which is cesium. There it is. So 1 of that guy, leave him blank. 4 of this guy, and 1 of that, leave it blank. And there's my answer. So that concludes that worksheet. All right. We'll see you next time. Have a great night.